Hello, my name is Mauro Margalho. I am a professor and researcher at the University of Amazônia. I would like to invite you to see this lecture given by teacher Fabrícia Costa. It is about a new type of network computer proposed by me called CoDPON, Continuous Displacement Plane Oriented Network. At the end of the presentation, I will let my contacts for collaboration purposes and criticism. Hope you enjoy. Thank you very much.
Hi, my name is Fabrícia Costa, and I'm here to present the project developed by Dr. Mauro Margalho from University of Amazônia, placed in the north of Brazil. This project is a new kind of network called Continuous Displacement Plane Oriented Network, or CoDPON. It was inspired by the Disruption Tolerant Network, the DTN. As the DTN, the CoDPON was created to solve communication problems such as high error rates, big delays, and lack of connectivity. As it has intermittent connectivity, the nodes keep information that are going to be transmitted as soon as possible. The DTN requires a high cost and a complex implementation, like specific softwares and hardwares, and the modification of the TCP layer. Although the CoDPON network is inspired by the DTN, you will notice that this is a much cheaper project. The CoDPON was created to help the integration from the social government programs among remote communities. Our scenario in this pilot project is Marajó Island. It is the largest marine fluvial island in the world, placed in the north of Brazil. It has about 50,000 kilometers squares and a very low demographic density. Due to its hydrographic richness and natural features, the fluvial mesh is used as the main transportation way by its population. Alternative solutions could be implemented as the use of satellites. However, the costs with the rent of the link in this region is as expensive as maintaining a school in this area. Now, let's talk about the CoDPON terminology. First, let's talk about the nodes. They are mobile vehicles and have a unique identification. They move regularly between predefined points. In this project, a node is a boat that operates with routes, dates, and times pre-established. Now let's talk about the peer base station. The peer base stations are fixed points previously mapped where nodes make scheduled stops. Every scenario has a unique peer base station matrix that allows a hydrographic reference location at low cost. It could be used as GPS, but it would make the project much more expensive. This is one example of a peer base station matrix. It contains the hydrographic distance from Belém, the capital, to the other peer base stations like Portel, Melgaço, Bagre, Breves, São Sebastião da Boa Vista, and Muaná. Hydrographically, Muaná is closest to Belém with a 106 kilometers distance. Now let's talk about the displacement plan. It is the route to be traveled by nodes, including journey times and stop times. Each node has its own displacement plan. Let's take one example of a trip from Breves to Belém. In this case, the source peer base station is Breves. The destination peer base station is Belém. There is one stop point in Muaná. The estimated time between Breves and Muanan is 3 hours. The anchor time in Muanan is about 20 minutes. This time is used for passengers' embarkation and disembarkation. CoDPON Data Application in Transit, or DACT. It is the name given to the part of the applications that it is in transit between the source and the destination peer base stations. The DACTs are received at a source peer base station, where the source application was started. Then, a set of identifiers allow the correct delivery of the data. Records of DACTs are stored in XML format. The Embedded Kit of Displacement, or CAD. The CAD contains a microcomputer with solid-state disk to ensure more robust and persistent storage. A distro of a free operating system, Ubuntu server, is being tested, and a wireless network set for communication in ad hoc mode, consisting of a radio 802.11 and omnidirectional antenna. Except for the antenna, the CAD is housed in an airtight box that protects it from the frequent weather changes in the Amazon region. CoDPON Communication Protocol. It is important to mention here that each node runs both client and server modules. The client module. It has the responsibility to be emitting continuously connection requests to the server module. When it connects successfully to the server, it sends the peer base station the destination of all DACTs aboard. If any of these attributes match a destination node, it begins the transfer of a DACT copy to the server. The transfer process is encrypted, creating a level of logic security in the system. The server module. It has the responsibility to be monitoring on a predetermined point, waiting for connection requests from clients that are in the same range. In this interaction process, the server will compare the identification of the peer base station destination with the displacement plan of the node. If there is a shorter path to the destination, the DACT is copied. Even with the successful transfer, the original mode, or boat, will continue carrying the DACT, which will be discarded at the destination after verification of replication. In this example, the application begins in a school. It is transmitted by a radio to the peer base station. The peer base station is placed in the seashore. It is going to transmit a DACT to the first boat that has the destination in its displacement plan. If during this trip, this boat crosses with another boat that has a shorter path to the destination, the first boat delivers a copy from the DACT to the second boat, and it works the same way if the second boat crosses to other boats. The implementation of CoDPON network could be used for many applications, especially in eHealth and eGov. And this project could be used for reservation beds in the SUS Unified Health System in Brazil and issuing documents.